Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be looking at 7.1. 7.1 is looking at segment length and midpoint. So we're going to look at how we calculate the length of a line. We're going to look at how we determine the midpoint of a line. Some of this is a little bit of review from 8th grade. If it's new material, also great. If it's review, great. So let's go ahead and get started. And we'll pull it up here on full screen today. So the first thing we want to be able to do when we're looking at a line is determine points that are what we refer to as collinear. Now, as the name might imply, collinear implies points that are on the same line. Collinear, so same line. So for instance, if I had a diagram here, let's say A, B, and another point in the middle somewhere, call it C, I could say that A, B, and C are collinear. Okay? Because they're all points on the same line. Collinear means points on the same line. Now, another definition we want to be familiar with here is what's known as a segment bisector, but we'll get to that in just a second. Now, for a line that's, let's say, on the coordinate plane, determining the length might be a little bit more challenging because if it is a horizontal or vertical line, we can simply count the number of spaces, and that's the length of our line. For instance, let's say I had a line segment going from, let's say from -4 to +3. And I asked you to determine that line, the length of that line segment. Well, between -4 and +3, if I was looking at this, okay, going from -4 to +3, you could literally just go and count the spaces. 1, 2, 3, 4, 5, 6, 7. So the length between -4 and +3 is 7. And you have a couple questions that are just like that. Okay. However, if you're trying to determine the length of a line segment that's on the coordinate plane, on the x and y axis, you can still do that if you have a line that is, let's say, horizontal, or if you have a line segment that is vertical. Then you can just that's vertical. You can just count the number of spaces. Right? That doesn't require a lot of work on your part. However, if you have a line segment that is non-vertical or non-horizontal, meaning that it is diagonal, well, then you can't just simply count the number of spaces between the 2 points. That takes a little bit of work, which we'll get to here in just a second. So the other thing that you're asked to do in this section is be able to identify the midpoint of a line segment and also be able to define what a segment bisector is. So a bisector is a line or a line segment that takes a line or a line segment. Let's say a line, let's say AB here. And a line bisector is a segment that cuts that line into 2 equal parts. And again, we're going by definition here, not necessarily by my diagram. But if the line segment divides the original line segment or line into 2 equal parts, then this is what we refer to as a line or a segment bisector. So one of the questions on your assignment asks you to define that in your own words or give an example. Again, as long as you are able to justify it, I don't need the textbook quote-unquote definition, but that is what a line segment and a bisector is/are. So on that, when you draw a line bisector or a segment bisector, the point where that line intersects your original line, that is what's referred to as a midpoint. A midpoint is equidistant from the endpoints of the line or the line segment. So if I was looking at, let's say, line segment AB, then the midpoint, we'll call that M, is the same distance to A as it is the same distance to B, or AM is the same distance as BM. So those are some of the definitions involved in 7.1. Other than that, we are looking at being able to calculate, the distance between 2 points. We're also being able to calculate the distance between a line segment and a midpoint. So you have a couple questions that'll say, let's use this example here, AB with a midpoint M. Let's say I told you that the length of AB is 24 centimeters. I could ask you in a question then, well, what's the measure of AM and what's the measure of BM? So if M is given as the defined midpoint, that means it's right in the middle of A and B, which means it cuts AB into two equal parts. So AM is equal to BM, but also each of these are half of the original length. So if AB is 24 centimeters, that means AM is 12 centimeters, and BM is 12 centimeters. So you have a couple questions that look like that. Okay. From there, you have a couple questions involving the coordinate plane. So we're going to erase a little bit here. So you have a couple questions that involve the coordinate plane, and you're going to be given 2 points, and you're going to be asked to find the midpoint. Now, here, with the other examples, you're able to just kind of use a little bit of basic algebra to determine what the length of each line segment is supposed to be. Here, if we're drawing a line segment on the coordinate plane, then we need to determine where the midpoint actually is. So for that, let's say I have a point at -2, -2. Let's say I have a point at 2, 4. So for this line segment, I could ask you to determine what the midpoint is, the point in the middle of those two line segments. There are a couple ways to do this. The first and the most mathematical is, okay, we'll just simply find the average of each of the 2 points. So if I take -2 plus 2 divided by 0, and then -2 plus 4 divided by, or not 0, sorry, divided by 2. If I divide each of those by 2, then that's going to tell me where the midpoint is, right? So -2 plus 2 is 0, divided by 2 is 0. -2 plus 4 is 2, divided by 2 is 1. So that should, in theory, give me the point that is in the middle of that line segment. You can also do that just by looking at the diagram and saying, okay, well, for the x coordinate, what's between -2 and +2? And determining what x value is in the middle of those 2 points. And then you can do the same thing for the y values. Between -2 and +4, what's in the middle? Well, that's +1. So you can determine the midpoint algebraically, or you can determine the midpoint by looking at the graph. Either is acceptable for me, so long as you guys are showing your work. Okay. That's it for today. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.